Okay, fire away, Nicholas.
Okay, so as Heidi mentioned, so I'm Nicholas Micalleff, and I just joined Swansea University as a lecturer in computer science. So in today's talk, I will present the research that I conducted in my previous role at New York University in Abu Dhabi. So this is basically, as I was telling Heidi, this is an extension of a presentation that I'm doing next month at ICWSM. So for ICWSM, they only wanted 5 minutes. So I felt that I need to talk about more things. So I extended this presentation to 12 minutes, something like that. So I conducted this research in collaboration with Marcelo Sandoval Castaneda, who was my student at New York University, Abu Dhabi, Adi Cohen, who is a fact checker at Memetica, and Professor Mustaq Hamad and Professor Shujan Kumar from Georgia Tech, and Professor Nasser Mamin from New York University. So let's start. A common technique that is used to spread misinformation in social media platforms is to use cross-platform links to increase reach and evade detection by a single platform. So the challenge here is that the post might not contain explicit misinformation, but it does link to a YouTube video that contains misinformation. Now, such an approach was pretty common during the COVID pandemic. So for example, this is a common video that was used to spread false claims about 5G, which was spread on multiple platforms to increase the reach of misinformation video. So as you can see from the video, so this particular instance of the video was shared 1.1 million times, but this was not the only one, the only instance. So this video was shared, was uploaded on YouTube multiple times. It was shared on several platforms. So this is an important problem because it is a fairly common practice, but also cross-platform links to such multimodal misinformation have been shown to have more impact than using only textual content. But not only more impact, they are also they also spread more. They spread more deeply than just textual content. Hence, to reduce the impact of post and video pairs that spread misinformation, it is important to detect their content and warn users. However, the problem is that research found that less than 1% of post video pairs that contain misinformation get deleted or flagged. And it takes an average of 41 days for you to delete COVID-19 related misinformation videos. This gives misinformation spreaders ample time to increase the reach of their videos by sharing them as links in posts on multiple social media platforms. Now, the key impediment to detecting misinformation in post and video pairs is that standard text-based misinformation detection algorithms are not effective. And we did prove this because we found that, so with our data set, we found that 49%, at most 49% of the tweets get detected by standard text-based classifier, which is not that much. Now, the problem is that these classifiers only consider the text within the post, which, as you can see in the example, might not be enough to determine whether the linked video contains misinformation. The content of the video and the relationship between the post and the video need to be considered to be able to produce a better judgment on whether the post and video pair are spreading misinformation. So in this research, we address this problem in detecting misinformation by creating a data set of post video pairs for multiple platforms. We characterize how videos are used to spread misinformation, and we automate the detection of post video misinformation. Now, we do not only consider misinformation. So we also consider counter misinformation. Now, counter misinformation is when people are denying misinformation, they are denying false claims. So in this case, they are denying that 5G is making people sick and 5G is the real cause of the pandemic. Now, so why we are looking at counter misinformation? Because in our previous work, we found that inclusion of counter misinformation messages can increase the effectiveness of misinformation detection. So in our previous work was publisher big data, and we talk a lot about the effect of counter misinformation, how it helps to detect misinformation. Now, counter misinformation is still understudied topic, and including it in our work allows us to also characterize how videos are used to counter misinformation, and not just how videos are used to spread misinformation. In this way, we start to shed light on how platforms could leverage a counter misinformation post-video pairs to combat misinformation. Now, to conduct this research, we created a data set of 3,000 posts that link to YouTube videos. And these 3,000 posts consist of 1,000 posts from Twitter, 1,000 posts from Facebook, and 1,000 posts from Reddit. And these posts link to 991 unique YouTube videos. So these posts discuss various conspiracy theories that link COVID-19 to 5G. We manually labeled our dataset to understand how videos are used to spread misinformation and what kind of videos are used to fulfill this purpose. So while doing this labeling, we created a taxonomy, and we found that the type of YouTube videos used to spread or counter misinformation are explicit, implicit, neutral, ambivalent, and others. And the relationship used between the post and the video was mostly supporting post, related but does not support the post. We found also contradictions in unrelated videos, but we also found videos that support but are taken out of context. So I want to highlight that. So one of the main contributions of this research is this creation of the taxonomy, together with the corresponding manual created dataset of these 3,000 post video pairs from these three platforms. And of course, the dataset consists of misinformation, counter misinformation, and other tweets. Now, during the characterization of the post video pairs, we find that most videos either support post or are taken out of context. We also categorize the type of content present in the video, and we find that most videos contain explicit misinformation, with only a few containing implicit misinformation. Now, with implicit, we find that it's way more common for misinformation tweets rather than counter misinformation. And we also found that Reddit was significantly different. So how videos were used on Reddit was significantly more different than the other two. Yes. So after the analysis of the label data, we used the data to conduct 4 experiments to test several classification models that use cross-platform features to find the best setup to automate the detection of post-video misinformation, counter misinformation. Now, the cross-platform features included the text from the post. They included the video title, the video description, the video transcription, and other metadata that we extracted from videos from YouTube. And we used standard classification models such as logistic regression and SVM, but we also used more advanced models such as BiLSTM. Overall, we found that the best performing model was using multitask learning, and with regards to features, besides the text in the post, the best one was using the title, the video title, and the transcription of the video. In the paper, there are more details about the setup of the experiment. So there are a lot of technical details, and it explains as well how we used bad representations to model our data. However, in this talk, I want to highlight the main finding of this research, which is that we did not experience a decrease in classifier performance when using diverse data from the 3 different platforms. Now, as you can see from the numbers in the bar chart, the tested models mostly achieved F1 precision and recall greater than 0.75. And we obtained similar numbers when we tested these models using only Twitter data. So using only Twitter data and using the 3 platforms, we obtained similar precision, recall, and F1 scores. That shows, yes, they are similarly effective. Now, why is this important? So this is important because using data from multiple platforms not only strengthens the robustness of the classifier, but it could also decrease the time required to train misinformation, counter-misinformation detection models for new topics, which would in turn reduce the spread of misinformation. So it would reduce the spread because rather than taking a couple of weeks to train a new model from one data set, by using data from multiple data sets, one could reduce the training to a couple of days. And that means that you have 10 days in which you are detecting misinformation, which before you weren't. So cross-platform classifiers could also be of benefit to the fact checkers because they could help them gain more insights about how debunked videos are used on multiple platforms. So this could make the fact-checking process less time-consuming. Also, even social media users could benefit from such a classifier by having more context about the relationship between the post and video, but also the type of misinformation that the video contains. So this added context could help people make better decisions, which could prevent them from clicking on the links that direct them to misinformation videos. In conclusion, I want to highlight the two main contributions of our research. So there are other contributions, but these are the main contributions, which is the definition of this manually created dataset of 3,000 post video pairs from these three platforms, which link to 191 unique YouTube videos. So this is the first in its type. So there aren't datasets like this around. And we use this dataset, we make use of this data to address the problem of the ineffective detection of impactful cross-platform post-video misinformation by defining classifiers that use features from multiple platforms. And we do find that these classifiers obtain a reasonable performance in detecting misinformation, counter-misinformation, because by using only text classifiers, one achieves 49% detection, but with using this, it can go up to 82% detection. For further details, feel free to contact me. I don't think that the paper is online yet, but I would be happy to share the PDF. Thank you for your attention.